All of the problems covered in my videos can be downloaded at statisticsworkbook.com. If you go to the website, click on the PDF. You can download a copy of the workbook for yourself. Also on the website, you'll find links to all of my statistics videos, not just the ones I've uploaded to YouTube. I've uploaded nearly 100 videos that you cannot find on YouTube. So, I do hope you'll check out statisticsworkbook.com. Alright, let's begin our problem. Hello and welcome back. In this exercise, I'm redoing problem 4.4b on Bayes Theorem because I want to do it in a slightly different way than I've done in the first video. The first video we went through and responded to these problems using the formulas that you would have found in your textbook and doing all the calculations with probabilities. In this exercise, in this video, I want to do this in a way that sort of bypasses a lot of those formulas, and maybe will make it a little bit easier to see just what's going on. So just to summarize the problem, so here we've hired a new chef at a restaurant, and we see that this new chef has a satisfaction rating of 98% versus the current chef has a satisfaction rating of 80%. And at the moment, the current chef is producing 75% of the meals, and the new chef is producing 25% of the meals. So, in the first exercise, we went through and calculated a bunch of probabilities, and the first two weren't too bad, but then the last few got a little bit tedious. And this time, let's start a little different. This time, let's imagine that we're producing 100 meals. I'm going to use 100 because then we can work with whole numbers. We could work with 1, but then everything's working with decimals, and we get back to some of the challenges in dealing with probabilities. It's just harder to visualize decimals. So here, if we start off with this restaurant produces 100 meals. So who's producing those meals? Well, we have our two chefs producing those meals. We have the new chef and we have the current chef. Of those 100 meals, the new chef is preparing 25% of them, so that's 25 produced by the new chef and 75 produced by the current chef. Okay, so we've divided it up among who's producing them. Now let's split it up by quality. Is it good or is it bad? Is it satisfactory or is it not? So for the new chef, who's producing 25 meals, how many of those are likely to be satisfactory? So if they have a customer satisfaction rating of 98%, then let's assume that 98% of those 25 meals are going to be considered good. So 98% of 25, that means that 24.5, so this is 0.98 times 25, 24.5 of those meals are considered good, and so the other half of a meal is bad, let's say. So good and bad. And that's the same calculation for the current chef, who has, let's say, bad and good. So the current chef has a customer satisfaction rating of 80%. So of those 75 meals, 80% of them are good. So this gives us 60 good ones and leaves 15 not good ones, gross ones, bad ones. So there we have 100 meals, and we've got it broken down by who's producing them and how many are good and how many are bad. Now let's get into our problem. Part A. What is the probability of having a new chef prepare your meal? So if we look at that probability of the new chef preparing my meal, well, they're preparing 25 out of 100 meals. 25 out of 100, so that probability 0.25. So there's 0.25. So that one's relatively straightforward, right? That was really given to us right there in the problem. Now, moving on. What is the probability that if the new chef prepares your meal, that you'll be satisfied? So here it's saying, okay, the new chef prepared my meal, and I'm going to be satisfied. So that means that the meal that I am consuming, I know that it is one of these 25 meals. So I know that it's one of those 25 meals. So then what is the probability that given I am eating one of those 25 meals, what's the probability that I'm going to be satisfied? So then that's going to be the probability that it's a good meal, and given that it's produced by the new chef, well, that's simply, there's 24.5 out of those 25 meals that he produced are good, and so this is our 0.98. And again, this one was relatively straightforward. It's given to us right there in the problem. So here I have this probability that it's good, given that it's produced by the new chef, 0.98. Okay, now moving on. What is the probability of having your meal prepared by the new chef and being satisfied? So now I don't know who's producing it, but I want to know what's the probability of both having it prepared by the new chef and being satisfied or getting a good meal. So here we're looking at the intersection of these two events. So let's see, let's take some green. Whoops. So here we're looking at the probability that it is good and produced by the new chef. So how can we calculate that? Well, the number of meals out of those 100, the number of meals that satisfy both those criteria, it's produced by the new chef and it's good. We just follow the branches of that tree down to our number, and here I see that, well, 24 and a half of those 100 meals satisfy those two criteria. It's produced by the new chef and it's good. So 24 and a half out of 100, and so this is going to be 0.245. Now, using the formulas from your textbook, this would have been obtained by multiplying the probability that it's produced by the new chef times the probability, times the probability that it's good and produced by the new chef. So that would have been simply this value times this value, and that would give us here. So we can go through the calculations using our probabilities, but using this tree, this graphic, I can see it's simply the number of meals that satisfy both of those criteria divided by the total number of meals that are being produced. Okay, so that's relatively straightforward, I hope. Now, part D, without knowing who produces your meal, what is the probability of being satisfied? So now we're just looking at, I don't know who's going to produce it. What is the probability that I'm going to be satisfied? Or let's say, keep our notation constant here. What's the probability of getting a good meal? Okay, well now I look at those 100 meals that were produced. If it's produced by the current chef, 60 are good. If it's produced by the new chef, 24 and a half of them are good. So that means the probability of getting a good meal without knowing who produces it is 60 plus 24.5 out of the total 100 that were produced, and this is going to be 0.845. Okay, so we've got, again, a very simple method of calculating that probability, which if we had used the formulas, this would have been an application of the addition law, which of course brings me to a good point. This simple calculation using this breakdown is reliant on these events being mutually exclusive. So if it's produced by the new chef, it can't also be produced by the current chef. It's either one or the other. Similarly, it's either good or it's bad. All of these events are mutually exclusive. Okay, and so for that reason, this calculation, this simplified calculation, works. So moving on to part E. After consuming your meal, you find that it was delicious. What's the probability that it was produced by the new chef? Okay, so now this is application of Bayes' theorem, which, look in your textbook. This is a fairly tedious calculation if you're using all of these different probabilities. But using this method of, here I've got 100 meals, well, it's a little bit more straightforward to work with, or to calculate. Here what we're trying to figure out now is the probability that it's produced by the new chef given that it's good. So I eat it, that was a delicious meal. What's the probability that that was made by the new chef? So what we need to do, first figure out, well, how many meals are good, and what's the percentage of those good meals that were produced by the new chef. So in this exercise, we've already calculated these values, right? And I already know that the total number of good meals that are produced are 24.5 plus 60. Those are all of the good meals that are produced. Out of these 100 meals, there's 24.5 plus 60, so 84.5 meals are good. Of those, how many were produced by the new chef? So the new chef, well, they produced 24.5. And so here we're just really looking at the percentage. What's the percentage of the good meals that were produced by the new chef? And so in this exercise here, 24.5 divided by, let me grab a calculator here and we can do this. Okay, so now if I go, let's see, 24.5 divided by 24.5 plus 60. So round that 2.29. 0.29. And there we have our answer, 0.29. Let me fill in part D. Part D, this one here, 0.85. Good. Okay. So hopefully that method of calculating these probabilities is a little bit easier. We don't have to necessarily use all of these formulas. We can just talk about number of meals, number of cookies, chairs, whatever. We can break it down into something a little bit more tangible rather than dealing with probabilities, which are sometimes more abstract and difficult to wrap one's head around. So hopefully this method, we get all of the same answers as we did in the first video on this problem, thank goodness. And so hopefully this approach will be a little bit easier for you to digest. Okay, good. Thanks for watching.